Good morning, all. First of all, let me thank the organizers for giving me this opportunity to present my work. I'm going to talk about hierarchical self-assembly of nanoplatelets in binary solvents. This is the outline of my talk. First, I'll introduce the system and then experimentally study the properties of the system and then made some observations out of it. And then I'll conclude with a phase diagram. And of course, there are factors that regulate the self-assembly of colloids or macromolecule in the suspensions. So two of them are hydrophobicity and solvation of different charge species, where we can see the importance of the hydration in the system. Static interactions can be tuned even in the colloidal systems. Then what defines self-assembly pathways? So is a subtle balance between hydrogen bond formation and hydrophobic interactions. And how do we introduce hydrophobicity into the system? So one of the best findings that we did was introducing alcohols into ecosystem, which is or else hydrophobic co-solvents such as monodihydric trihydric alcohols, and modulate these two forces through a combination of direct solvent particle and solvent mediated interactions depending on the size of the alcohols. And we demonstrate a method to tune the interaction potential and the resulting phase behavior and microstructure. And we extensively examined the dispersion stability, aggregation, gelation behavior, and of course, and also liquid crystalline. Uh, the system consists of nanoparticles dispersed in alcohol water mixes. The alcohols used here are ethanol, methanol, propanol, and glycerol. And these are my ingredients that I used in my study. You can see on the right side, these are the TEM images of lepnite, where you can see uh, they are platelet-like structures. As you can see here, the diameter is 25 nanometers and it has a thickness of 1 nanometer. And once we introduce alcohol replaces, they get absorbed onto the clay surface and it replaces the water molecule, and all the water molecules can be replaced once we reach full 100% alcohol system. And these are the alcohols we used in our study: methanol, ethanol, propanol, glycerol, and ethylene glycol. Before going into the main study, let me just state the phase diagram of lepnite aqueous suspensions. Uh, it depends on what time scales you are looking at exhibit of fluid behavior. Uh, First, we explored the physicochemical properties such as surface tension, hydrodynamic radius, zeta potential, and conductivity of the system, where we used 0.1 weight percent of nanoparticles and alcohols going from 0 to 100%. We can see here the size of the aggregates going up, uh, the green one. You can see the size of the aggregates going up as we increase the alcohol concentration, and also zeta potential. The surface charge also goes down. It goes down from minus 36 to 0. Next slide. The complete phase separation happens and we destabilize the system overall. And the surface tension behavior follows similar behavior like water alcohol system. And other important observation was the conductivity as function of alcohol concentration. You can see that the conductivity goes down, decreases. It is due to the formation of ion-ion pairs in the system. We found an important and useful scaling relation, clay suspensions in alcohol solutions. And we found a correlation between size, zeta potential, viscosity, and surface tension with the solvent polarity. This is only, we have shown only the size of the aggregates there in the system, but it is the behavior is seen even for the zeta potential, viscosity, and surface tension. And the universality is observed in this case is independent of aspect ratio. We tested this for two aspect ratios. One is 25 and another is 250, which is for montmorillonite. And we went on to see what happens at higher concentrations, where usually leptonite forms gel around 2%. And we actually added all alcohol from 0 to 100% and see visually what happens. And beyond 50%, the system appears to be turbid, and it is due to the formation of aggregates. In this case, more scattering is there. And after a few hours, what it did is beyond 50%, the system is completely phase separated.